So today, Academic Daddy will be teaching you everything about thermodynamics. So first, you need to know that thermodynamics is the science of energy transformation. So thermodynamics is the science of energy transformation. It's the science of energy transformation. It's the science of energy transformation. Now, when you know this, you can as well know that it is also the science that relates or that talks about the relationship it's the science that talks about the relationship between energy, work, and matter. So, in simple terms, thermodynamics is the science of energy transformation. It is the science that relates energy, work, and matter, or the science that talks about the relationship between work, energy, and matter. So, if you know this, now that you know this, the next thing I want you to know is what we call so you need to know that we have two major types of thermodynamics. We have the classical thermodynamics, and the classical thermodynamics talks about the viewpoints of macroscopic, that is looking at things, all this relating science with regards to how heat is affected in a big way, macroscopic. But when you have to do with molecules or little in a microscopic view, we use the statistical thermodynamics. So this one looks at it in a microscopic view. So first, you know the definition of thermodynamics. Second, you know the types. Now the third thing I'm gonna need you to know is what we call terminologies associated with thermodynamics. There are so many terminologies, you can't even cover everything in one video, but I will give you the basic ones. So, terms associated with thermodynamics. The first one is what we call universe. Now, when we talk about universe, we are talking about the earth. We are talking about the earth, the space available to man to perform all other things it does. So we can say that universe is the physical chemistry. It describes the system and the surroundings. So universe is simply all about system and surrounding. So system plus surrounding makes up the universe. Then we have what we call system. So system is the part of the universe under investigation or under observation, the part of the universe under study. So the part of the universe under study. That's what system is. It's the part of the system under study. So it is the portion that is enclosed by what we call boundary. So the next term that you need to note is what we call boundary. So this term boundary is actually demarcation, or we say that boundary is the allocation or the demarcation or the wall or the enclosure between the system and the surrounding. So boundary. So it is the demarcation between the system and the surrounding. I just had a very strong class this evening, so don't mind the voice. It might be sounding the way you like. But now the last one is surrounding. So surrounding, it constitutes everything outside the system. It is the part of the universe outside the system. It is the part of the universe outside the system. So it is everything outside the system. Or you can say it is the remaining part of the universe outside the system. Or you say when you do universe minus system, what is remaining is surrounding. So once you know this, you need to know now that we have things like isolated system, adiabatic system, and the rest. So, but these are the major terminologies to note. So when we start talking about things like, for example, homogeneous system. Homogeneous system. A system is said to be homogeneous if it is in one phase. Example, solution. So if it's in one phase, it's a homogeneous system. Now we have what we call heterogeneous system. If you notice, my handwriting is not looking the way it is. So anyway, so when a system is not in one phase, when it's in two phase, or it has different phase, two or more phase, we say it's a heterogeneous solution. Sorry, not a solution. Heterogeneous is a heterogeneous system. And you know, example is colloid suspensions, all those things that are not solutions. Then we have what we call phase system. So a phase system describes the portion of a system that is homogeneous but different and separate from others. It describes a portion of a system that is homogeneous but different and separate from others. I'd like you to get your pen and paper so that as I'm teaching you, you are writing everything out. Now, we now have universe, we have boundary, we have surrounding. But I need you to note that the topic thermodynamics is mainly, or should I say, is focused more on system. Of all these terms here, focused more on system. So if you want to go and study the universe, you go and read astronauts. Boundary, maybe you go and take a job for security personnel. Surrounding, cleaner can do. But when it's thermodynamics we're talking about, focus more on systems. So that is why we are going to do what we call types of system. Types of system. So under the types of system, we have open system. Open system. So a system is said to be open. A system is said to be open if it's capable of exchanging matter, example oxygen, air, and energy, example heat, with the surrounding. So when you can exchange O2 and heat, or energy, or matter and energy, you say it's an open system. Now closed system, we have the second type. This is the first one, this is the second one. A closed system is a system that can exchange heat with the surrounding, but cannot exchange matter with the surrounding. So it's capable of exchanging no matter. It's capable of exchanging energy, no matter, plus yes, Yes, image.